Hello everyone. Um, Welcome to this lecture series, and here we'll see about how this big programming usage and examples. In this session, we'll explore the different types of data types and how we use data types in this coding, efficient coding, and we'll see how the real world examples will illustrate in the usage. So I'm Dr. Husna. Today I'll guide into this topics. So, well, now you can see here I have written a program of this is a program written in the PIC 18. So here we can see that we'll quickly revise why the data types are important. Data types defines the size, range, and type of the data variables that can be stored. Why I'm telling the data types is because it is an important to how we are storing the data in this. And here before going to this program, we'll see the data types and characters, everything. So common data types in embedded is like char, and we know this it is in 1 byte, and the integers 2 byte, float is 4 byte, long is 4 byte, unsigned is it may be of positive or negative, and bits will be of 0 and 1. So all this will be bits configuration. This is the data types. And similarly, how we use in the PIC programming is like we are saying we configure the ports when you're doing the program. So for configure we use the tris. So the tris port is like it gives the direction to the port, like to send the bits to the directing the bits to the store in the particular port. So initially, if you see this program, we have assigned all the tris B, tris C, and tris D as in 0. So this instruction is like we have make SNS and this is an output device. So and I have done this here. You can see there is a bitwise operation of 35 and the 0F. So this performing this bitwise operation of AND is like we are going to mask only the lower of 4-bit value. And similarly, I have done this R value for R value 0x04 and 0x68, which ensuring this will mask with the remaining values. And here we have done the for port D is an XOR value. It's like bitwise XOR operations between these 2 bytes. And then bit inversion, bit inversion I have done now for this particularly of bitwise not for the 0500, and this performing this right shift and left shift. Here you can see how I have to perform this left shift and right shift is like shifting the bits to this, and then there is an infinity loop. Why I'm telling this, like these are the different logical operators where we can use to uh, do it. So when we are doing this program, we do all the operations together in all the ports. So in next programming, here there's like say it is used for toggling the bit of port B and port C continuously with every 250 milliseconds. So initially what it means like we have to toggle the value. So I have assigned the value of port B and port C. The port B will is like 0x055. That means like 55. That is 0101. And then even though this 5 is 0101. So you get 2 times of 0101, 0101. And for A is like 10. That is of 1010, 1010. And then I will go for the first iteration. In first iteration here I have mentioned as an bitwise port. So this bit is going to be shifted the one by one. So initially it will be a 0101. After masking of shifting the bit, again it will become as 1010. And similarly for port C also its shifting will get, and for doing everything in the delay of 250 milliseconds for every iterations. So every iteration this loop will be repeatedly this thing, and whenever it is comes up 1 and 0, it will create a toggling and it will be start blinking it. So why we are using this bitwise inversion is like we are going to flip 0 means 1, 1 means 0, so it will automatically it will flip. After flipping it is again to show the output as an tris put. And then We use the delay functions, and we are doing this for toggling the output to the entire for entire all the ports, and it is loop will be run in the form of infinite. So here we can see the same program, but we are using the XOR operator. Similarly, same thing, we are assigning the port B, port C, port D with the 0x50, and initially we are iterating with the alternating pattern. Like we are first initially we are doing with the port B means 0x55 in an XOR of 0x0f. Again, we'll toggle the bit like 0 means 1 and then 1 means 0. So again, for every 250 seconds, it will start blinking the delay every delay of 250 delay it will start blinking it off. So this loop also will be continuing with the infinite loop. And why we are what is the key concept is like we use a bitwise operator. Like for toggling, always we try to use the bitwise operator, and for the port configuration we use the address functions. And we have the software delay, like where we use all this thing, all this type of program is like when we are going for LED blinking and for testing the digital signal or the debugging the control. What is a possible enhancement, like sorry, like we can use instead of software delay we can use for the hardware delay, and we try to adjust the loop in the precise timing. So here there's a one more program, like to get the RB0 and to RB7 after inverting. So here what is like I have to invert the value. So initially, like interest P conditions, interest port we have configured, and here you can see this I have used we have configuring the interest bits in the bit by bit, like initially of RB0, and again to C port is like RC7 port as an output port. So every output is like we read the input and we invert and we store the input. So if it is of RB zeroth value means again that value will be storing in the seventh value. So where we'll use this, like this type of function we can use for the internally push pull in pull up optionally we can use it. And how so this type of program will be help for debouncing the input if we have the button that time we can use for